Good morning, student. Welcome back to physics revision class. So in the last class, we ended with the question difference between interference and diffraction. Right. So today start with the question that is in part C. Arrive Snell's law of refraction using Eigens Principle of refraction of a plane wave. Right. So this is from the wave topic. So Snell's law is the ratio of sine of angle of incidence to the sine of angle of refraction. That is sin I by sin r is always equals to a constant. So that constant is taken as the refractive index. So that we are going to derive by using the Eigens principle, right? So Eigens principle, what it states means. So if we have source, right? So from this source, the light waves are emitted in the form of wave fronts, right? So this we call as the wave fronts, right? So on each point of the wavefront, right? So on this wavefront, each point acts as a source of the secondary disturbance, right? So source in the nಮಗೆ ಬರ್ತಾ ಇದೆ waves ಬರ್ತಾ ಇದೆ. So those waves we taken as a wavefront. So ಈ wavefronts ಮೇಲ್ಗಡೆ number of points ಇರುತ್ತೆ. So each point acts as a source for the secondary wavelets, right? So secondary disturbances ಗೆ source ತರ behave ಮಾಡುತ್ತೆ, right? So from these wavefronts, right? So these wavelets are spread in all the direction, right? So ಇಲ್ಲಿಂದ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿರೋ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಎಲ್ಲಾ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಕೂಡ ನಮಗೆ spread ಆಗುತ್ತೆ with the speed of light, right? So that disturbance will move with the speed of light, right? So that is in all the directions. So all directions means it behaves as a sphere. So E point in the spread up by the waves, so that in the spherical wavelets, right? So sphere ಅಲ್ಲಿ ಎಲ್ಲ directions ಅಲ್ಲೂ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ disturbances produce ಮಾಡುತ್ತೆ, right? So same wise all the points acts as a secondary source. So hence from each point the disturbances will created. So those disturbances are called the secondary disturbances or secondary wavelets, right? So each point in the ನಮಗೆ disturbances ಬರ್ತಾ ಇದೆ. So ಅದು ಎಲ್ಲ directions ಅಲ್ಲೂ ಬರ್ತಾ ಇದೆ, right? So if we draw the common tangent to all these wavelets, so ಎಲ್ಲ wavelets ಗೂ ಕಾಮನ್ ಆಗಿ ಒಂದು tangent ನ ಡ್ರಾ ಮಾಡಿದ್ರೆ, right? So that tangent acts as the secondary wavelet, right? So this one becomes the primary wavelet and this becomes the secondary wavelet, right? So by using this theory, so we are going to discuss the Snell's law, right? So Snell's law by refraction, right? So that is question number 28. Right? So wavefronts are ಕೂಡ ನಮಗೆ different types ಇದೆ, plane wavefronts ಇದೆ, spherical wavefronts ಇದೆ, right? So here we are considering the plane wavefront, right? So plane wavefront means, so the wavelet here we are getting, so this becomes the primary wavefront, then this becomes the secondary wavefront. So from this it emits the wavelets in spherical shape. So ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಇಂದ ಕೂಡ ನಮಗೆ spherical wavelets ಬರುತ್ತೆ. So spherical wavelets ಗೆ tangents ನ ಡ್ರಾ ಮಾಡಿದ್ರೆ we get the secondary wavelet, right? So here we using this plane wavefront, right? So consider one refracting medium. So it separates the two mediums, right? So one refracting surface considered ಮಾಡ್ತಿದ್ವಿ. So that refracting surface separates the two medium, right? So above the refracting surface we will call that one as medium 1 and below the refracting surface we take that one as medium 2, right? So consider one plane wavefront. So which incident on the refracting surface. This one is the refracting surface, right? So one plane wavefront considered ಮಾಡ್ತಾ ಇದ್ವಿ. So that will be incident on the refracting surface with angle of incidence is right? So AB is the refracting surface, right? So wave AB is the incident wavefront. So AB is the incident right? So when the incident wavefront incident on the refracting surface makes with angle of incidence, that is I. So this angle of incidence is I, right? So if we consider this is the wavefront, so plane wavefront so that will move with respect to time. So time change after wavefronts it will cover the distance, right? So plane wavefronts move, but it is incident. So say AB is incident on the refracting surface. So the point A first touches the refracting surface, then the point B. So wavefront ಅಲ್ಲಿ 2 points considered ಮಾಡಿದ್ರೆ. So each if wavefront ಒಳಗಡೆ ತುಂಬಾ points ಇರುತ್ತೆ. So already ಹೇಳಿದಂಗೆ, right? So each point acts as a secondary source. So here I am considering the 2 points. So one is point A and another one is point B. So in between A and B we have many number of the wavefronts, right? So the point A first touches the refracting surface. So point A ಏನಾಗುತ್ತೆ first ಬಂದು refracting surface ನ touch ಮಾಡುತ್ತೆ, then it refracted. So that means it will move, right? So this point A is responsible again for the secondary wavelets. So ಈ point A ಮತ್ತೆ ಯಾವುದು ರೆಸ್ಪಾನ್ಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ secondary wavelets ಗೆ ರೆಸ್ಪಾಂಡ್ ಆಗುತ್ತೆ, right? So same as here B, right? So B ಇಂದ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ refracting surface ನ ಟಚ್ ಮಾಡೋದಕ್ಕೆ ಅಂದ್ರೆ, so that time is T, right? So if we draw the perpendicular from B, so BC is perpendicular to that of the refracting wave incident wavefront AB, right? So point B in the C ಗೆ reach ಆಗೋದಕ್ಕೆ ತಗೊಂಡಿರೋ ಟೈಮ್ ಎಷ್ಟಿರುತ್ತೆ T ಇರುತ್ತೆ. So in the same time the point B A moves further, right? So ಈ point A ಎಷ್ಟು ಮೂವ್ ಆಗ್ತಾ ಇದೆ, so it is moving in the second medium. So in the second medium the speed of the wavefront will decreases, right? So in the medium one the speed V1 is ಅಂದ್ರೆ, so in the second medium its speed becomes V2. That means V2 is less than V1, right? So that is the wavefront is traveling from rarer medium to denser medium, right? So again if you draw the perpendicular, so CD is the refracted wavefront, right? So angle C is the angle of refraction, right? So now right, so consider the plane wavefront. Consider the plane wavefront moving with velocity v1 which incident on the refracting surface and it travels into the medium 2 with speed v2, right? So v2 is less than v2, v2 is less than v1, right? So if t is the time taken to reach the point C by the point B, so point B refracting surface na touch agodakke ಎಷ್ಟು time ತಗೊಳ್ತಿದೆ t time. So in the same time A will move further in the second medium, that is up to the point D, right? So this is again perpendicular, right? So from the velocity, right? So v1 is equals to, so distance covered, that is BC divided by time t, right? So similarly velocity v2 that is equals to distance covered AD divided by t. So this we can write BC is equals to v1t. So here AD is equals to v2t, right? So from triangle ABC, so sin I that is equals to, so sin I is equals to opposite side by hypotenuse. So opposite side is BC and hypotenuse is AC, right? So similarly from triangle ABC, sin R that is equals to AD divided by AC, right? So BC is what? V1t divided by AC. So here AD is V2t divided by AC. So take on this one as first equation, second equation, right? So divide first equation by the second equation, right? So sin I divided by sin R, that is equals to V1T divided by AC divided by V2T whole divided by AC. So AC get cancelled, TT get cancelled, so we get V1 by V2, right? So from the definition, so V1 is equals to C by N, or N is equals to C by V, right? So V1 is equals to C by N1, so V2 is equals to C by N2. So substitute here, V1 is equals to C by N1 divided by C by N2. So C get cancels. So finally sin I by sin R, that is equals to N2 by N1, that is equals to N2. So this one is the Snell's law of refraction, right? So next to 29th question, right? What are matter waves? Write the expression for the de Broglie wavelength of a particle. Explain the term. So ಇದನ್ನ 2 marks ಅಲ್ಲಿ ಕೂಡ ನಾನು ಹೇಳಿದ್ದೆ already. So matter waves ಅಂದ್ರೆ the waves which are associated with the material particles. Then those waves we call as the matter waves, and how it relates with the de Broglie wavelength. So that is lambda is equals to h divided by mv, that is equals to h divided by p. So the 2 marks are kuda repeat agide, so that then necessary illa, right? So move on to the 30th question. Mention 3 applications of polarides, right? So 3 applications of polarides. So polarides are used to analyze and produce the polarized light. So polarides na ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we need to analyze, so study ಮಾಡೋದಕ್ಕೆ ಮತ್ತೆ produce ಮಾಡೋದಕ್ಕೆ. So ಏನು produce ಮಾಡ್ತಾ ಇದೀವಿ? Polarized plain polarized light na produce ಮಾಡೋದಕ್ಕೆ ಮತ್ತೆ analyze ಮಾಡೋದಕ್ಕೆ polarides na use ಮಾಡ್ಕೊಂತೀವಿ. So we using that in also in the polarized sunglasses, and also used to see the 3D pictures. So 3D pictures na ನೋಡಬೇಕು ಅಂತ ಕೂಡ ನಾವು polarides na use ಮಾಡ್ಕೊಂತೀವಿ, right? So those are the 3 applications of polarides, right? That is 30 applications of polarized. So the first one, it is used to analyze and produce plain polarized light, right? So second one, it is used in sunglasses, that is polarized sunglasses. We call that one as the polarized sunglasses, right? So next, it is used to see 3-dimension pictures, right? So it is used to see the 3-dimension pictures, right? So these are the 3 applications of polarides, right? So next, give the 3 characteristics of photons. So photon travels with the speed of light. So energy of the photon is E is equals to h nu, and the photon will not deflect in electric and magnetic field, and it is electrically neutral, right? So these are the characteristics of the photon. So and also we can write the momentum of the photon, right? So P is equals to, that is m into v, right? So question number is 31. Characteristic of photon, right? So in the first one is photon travels with speed of light, that is 3 into 10 to the power of 8 meter per second. So that one is the first characteristic of photon. So photon having energy, photon having energy E is equals to h nu or hc divided by lambda, right? So h is the Planck's constant, c is the speed of light, and lambda is the wavelength, right? So on the third characteristic is, so photon do not deflect in electric and magnetic field. So photon ಏನಾಗೋದು ನಮಗೆ ಡಿಫ್ಲೆಕ್ಟ್ ಆಗೋದಿಲ್ಲ. So and also it is electrically neutral. So photon is electrically neutral. So ಇದಕ್ಕೆ ಯಾವುದೇ ತರದ್ದು ಚಾರ್ಜ್ ಇರಲ್ಲ. So hence we call that one as electrically neutral. So on the next one is the rest mass of the photon is zero. Rest mass of the photon is zero. So 3 marks in ಕೇಳಿದ್ರೆ ಯಾವುದಾದ್ರು 3 points ಬರೆದ್ರೆ enough, right? So next, state any 3 features of the nuclear forces. So ಇದು already 2 marks ಅಲ್ಲಿ ರಿಪೀಟ್ ಆಗಿದೆ. So ಅಲ್ಲಿ ಇದನ್ನ ಮತ್ತೆ ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಳಿ ಅಥವಾ ಎರಡನ್ನ ರಿಪೀಟೆಡ್ ಅಂತ ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ. So forces of the nuclear force is a short range force, right? So nuclear force is independent of the charge, right? So ಇದು ಚಾರ್ಜ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಲ್ಲ. So force between proton and neutron is equals to force between neutron and neutron and force between proton and proton. So ಎಲ್ಲದಕ್ಕೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್. So nuclear force is the strongest fundamental force in nature. So nuclear force is strongest fundamental force. So these are the 3 characteristics of nuclear force. Next, explain LC oscillator, right? So question number 33. So already first year ಅಲ್ಲಿ oscillations ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಾ, right? So displacement of any particle from its mean position to and from motion ಇರೋದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, oscillation ಅಂತ ಕರೀತೀವಿ. So here the charge is oscillating, so that's why that device we call as the LC oscillator, right? So where L is the inductor and C is the capacitor, right? So when one inductor, so LC oscillator can again be one inductor. So inductor is connected to the charged capacitor, right? So inductor having the inductance L and capacitor having the capacitance C, right? So when inductor is connected in connected in parallel with the charged capacitor. So mention ಮಾಡಬೇಕಾಗಿರೋದು ಯಾವುದು ಅಂದ್ರೆ capacitor ನ ಚಾರ್ಜ್ ಮಾಡಿರೋ capacitor ನ inductor ಗೆ parallel ಆಗಿ connect ಮಾಡಬೇಕು, right? So when the capacitor is charged, so capacitor ಏನಾಗಿದೆ ಚಾರ್ಜ್ ಆಗಿದೆ. So now the capacitor gets discharged, right? So ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಇರುತ್ತೆ. So one plate of the capacitor ಅಲ್ಲಿ positive charge ಇರುತ್ತೆ, so another plate of the capacitor ಅಲ್ಲಿ negative charge ಇರುತ್ತೆ, right? So this capacitor gets discharged. So discharge means the charges are moving from the capacitor, right? So charges are moving from the capacitor is nothing but current is flowing in the circuit, because flow of charges per unit time we call as the current, right? So this current flows in the inductor, that is coil. So inductor na coil anta karitivi. When the current is flowing in the inductor, so EMF is induced in the coil, right? So ಇಲ್ಲಿ ಏನು ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ ನಮಗೆ EMF ಇಂಡ್ಯೂಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So ಇಲ್ಲಿ ನಮಗೆ ಚಾರ್ಜಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So ಇಲ್ಲಿ EMF ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So finally when the capacitance ಅಲ್ಲಿ charges gets completely zero, right? So charges complete ಆಗಿ zero ಆದಾಗ, so inductor ಅಲ್ಲಿ EMF ಏನಾಗುತ್ತೆ ನಮಗೆ completely we getting the maximum EMF, right? So that is again from the Faraday law of electromagnetic induction, induced EMF E is equals to minus L into di by dt, right? So due to this induced EMF which is linked with the conductor, so it induces the current, right? So that current is again starts to flow, right? So ಇಲ್ಲಿ induce ಆಗಿರೋ EMF ಇಂದ ಏನು ಬರುತ್ತೆ ನಮಗೆ current, right? So that current is again starts to flow in the circuit. So due to this current, the capacitor again gets charged, right? So ಇಲ್ಲಿ positive ಇರುತ್ತೆ, ಇಲ್ಲಿ negative ಇರುತ್ತೆ. So again the current is flowing means the capacitor will get charged. So complete EMF 0 ಆಗೋವರೆಗೂ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ ಕೆಪಾಸಿಟರ್ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಸೊ ಆಫ್ಟರ್ ಇಟ್ ಗೆಟ್ ಫುಲ್ಲಿ ಚಾರ್ಜ್ ಅಗೇನ್ ಇಟ್ ಗೆಟ್ಸ್ ಟು ಡಿಸ್ಚಾರ್ಜ್. ಸೊ ಇದರಿಂದ ಮತ್ತೆ ಏನಾಗುತ್ತೆ ಡಿಸ್ಚಾರ್ಜ್ ಆಗೋದು ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಅಗೇನ್ ಇಟ್ ಇಸ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಮೀನ್ಸ್ ಕರೆಂಟ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್. ಸೊ ಹೆನ್ಸ್ ಅಗೇನ್ EMF ಇಸ್ ಇಂಡ್ಯೂಸ್ಡ್. ಸೊ ದಿಸ್ ಆಸಿಲೇಟ್ಸ್ ಚಾರ್ಜ್ ಏನಾಗುತ್ತೆ ಒಂದ್ಸಲ ಇಲ್ಲಿ ಇರುತ್ತೆ, ಜೊತೆಗೆ ಅಗೇನ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ ಎನರ್ಜಿ ಇಂದ ಇಂಡಕ್ಟರ್ ಮತ್ತೆ ಎನರ್ಜಿ ಇಂದ ಕೆಪಾಸಿಟರ್ ಎರಡು ಕೂಡ ಆಸಿಲೇಟ್ ಆಗ್ತಾರೆ. ಸೊ ಒಂದ್ಸಲ ಇದ್ರಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದ್ರೆ ಇದರಲ್ಲಿ ಮಿನಿಮಮ್ ಆಗುತ್ತೆ. ಸೊ ಇದರಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದ್ರೆ ಇದರಲ್ಲಿ ಮಿನಿಮಮ್ ಆಗುತ್ತೆ. ಸೊ ಕನ್ಸಿಡರಿಂಗ್ ದ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸಿಚುಯೇಷನ್, ಸೊ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ರೈಟ್? ಸೊ ದ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್, ರೈಟ್, ಕನ್ಸಿಡರಿಂಗ್ intermediate situation. So ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಅಲ್ಲಿ, ಸೊ ಇನ್ ಬಿಟ್ವೀನ್, ಸೊ ಕಂಪ್ಲೀಟ್ ಆಗಿ 0 ಆಗಿರಲ್ಲ. ಸೊ ಸಮ್ ಚಾರ್ಜಸ್ ಏನಾಗಿರುತ್ತೆ ಡಿಕ್ರೀಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇದರಲ್ಲಿ ಸಮ್ EMF ಇಸ್ ಇಂಡ್ಯೂಸ್ಡ್. ಸೊ ಇಲ್ಲಿ ಕೂಡ ನಮಗೆ ಪೊಟೆನ್ಶಿಯಲ್ ಇದೆ, ಇಲ್ಲಿ ನಮಗೆ EMF ಇಂಡ್ಯೂಸ್ ಆಗಿದೆ. ಸೊ ಎರಡು ಪ್ಯಾರಲಲ್ ಇರೋದ್ರಿಂದ ಸೊ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ across the capacitor is equals to potential difference across the inductor or coil, right? So intermediate situation ಅಲ್ಲಿ ಎರಡರದ್ದು ಪೊಟೆನ್ಶಿಯಲ್ ಏನಾಗುತ್ತೆ ನಮಗೆ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಅಲ್ಲಿ ಎರಡರದ್ದು ಪೊಟೆನ್ಶಿಯಲ್ ಸೇಮ್ ಆಗುತ್ತೆ. ಸೊ ಕನ್ಸಿಡರಿಂಗ್ ದಟ್ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ across capacitor is equals to potential difference across the inductor. So we know the relation for the capacitance is equals to Q divided by V. So V is equals to Q divided by C. So this is the potential across the capacitor having capacitance C and it has the charge Q, right? So that is the EMF induced in the inductor is E is equals to minus L di by dt, right? So potential difference V is equals to Q divided by C, that is equals to minus L into di by dt, right? So now if we shift to the RHS, so L into di by dt plus Q by C, that is equals to 0, right? So again the current is flowing in the circuit, so that I will define as so rate of change of charge, right? So charge flowing per unit time na navena kariತೀವಿ, current anta kariತೀವಿ. So only few amount of charges are getting discharged, so hence I is equals to dq by dt. So substituting here L into d by dt, so in place of I dq by dt plus q by c, that is equals to 0. So now divide whole this equation by L, so this becomes d square q by dt square plus q divided by LC, that is equals to 0. So illiro L na divide madidre q divided by LC, and also we know that 1 by LC, that is equals to omega naught square. So that is the resonating frequency, right? So substituting here d square q by dt square plus q omega naught square, that is equals to 0, right? So this is the equation of S section. Simple harmonic motion, right? So last year kuda discuss madidvi, that is d square x divided by dt square plus x omega naught square. So x ಅಂದ್ರೆ displacement ಆಗ್ತಾ ಇತ್ತು, so mean position ಇಂದ displace ಆಗ್ತಿರೋದನ್ನ x ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ. So hence we are getting x there. So ಇಲ್ಲಿ ನಮಗೆ ಏನು displace ಆಗ್ತಾ ಇದೆ, charge is oscillating between the capacitor and the inductor. So hence we getting d square q by dt square plus q omega naught square, that is equals to 0, right? So this shows that the charge is oscillating in between the inductor and the capacitor. So LC oscillator andre, so a diagram, so Considering the intermediate situation, potential difference across the capacitor is equals to potential difference across the inductor, because these two are connected in parallel. So ಎರಡು parallel ಆಗಿರೋದ್ರಿಂದ ಇಲ್ಲಿ ಏನು potential ಇರುತ್ತೋ ಇಲ್ಲೂ ಕೂಡ ಅದೇ potential ಇರುತ್ತೆ ಯಾವುದೋ ಒಂದು particular time ಅಲ್ಲಿ, right? So that condition, here we getting the relation, that is second order differential equation. So this indicates the simple harmonic motion, right? So LC oscillator ಕೇಳಿದ್ರೆ ಇಲ್ಲಿವರೆಗೂ enough, right? So next, derive the expression for radius of nth orbit of electron revolving round the nucleus of hydrogen atom. Radius of hydrogen atom, right? So hydrogen atom consists of a nucleus, right? So ಅದನ್ನ actually Ze ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So hydrogen atom ಇರೋದ್ರಿಂದ Z value ಏನಿರುತ್ತೆ ನಮಗೆ 1 ಇರುತ್ತೆ. So 1 into E, so that is positive. So nucleus is always the positive, and the electron is revolving around the nucleus at a distance r from the nucleus, right? So somewhere here we consider the electron, so it is at a distance r from the nucleus, right? So it is moving with a velocity v. So electron is moving with a velocity that is revolving around the nucleus at a distance r from the nucleus, right? So here it is, the nucleus is positive charge and the electron is negative charge. So due to positive and negative charge, so here the Coulomb's law will apply. There is the electrostatic force between the nucleus and due to that of the electron, right? So that is electrostatic force, so that we taken Fe, right? So that is equals to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. So here Q1 is plus E, right? So Q2 is magnitude of E, that is E divided by R square, right? So definition ಅಲ್ಲಿ ಏನಿದೆ ಅಂದ್ರೆ ನಮಗೆ magnitude of the two charges. So one charge E ಇದೆ, so another charge ಕೂಡ E ಇದೆ. So minus E ಇದೆ, but magnitude ತಗೊಂಡಿರೋದ್ರಿಂದ here we take on plus E, right? So electrostatic force F is equals to 1 by 4 pi epsilon naught E square divided by R square, calling this as the first equation, right? So now the electron is moving around the nucleus, that is revolving around the nucleus with the speed v. So electron revolve ಆಗ್ತಾ ಇದೆ, so there is a centripetal force. So electrostatic force is responsible for the electron to move in the circular path, that is due to because of the centripetal force, right? So ಅದು ಎಲೆಕ್ಟ್ರಾನ್ ಅಂತ ಅಲ್ಲ, ಯಾವುದಾದ್ರೂ ಒಂದು ಪಾರ್ಟಿಕಲ್ ಅಥವಾ ಆಬ್ಜೆಕ್ಟ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ there is a responsible for the motion in the circular path is the centripetal force. So centripetal force is responsible for the particle to move in the circular path, right? So and that force is always towards the center of the earth. So ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ ನಮಗೆ positive charge ಇದೆ, negative charge ಇದೆ, so there is an attractive force, right? And also the centripetal force is always towards the center, right? So ಎರಡು ಕೂಡ same direction ಅಲ್ಲಿ act ಆಗ್ತದೆ. So centripetal force Fc, that is equals to mv square divided by r, right? Calling this one as the second relation. So from equation 1 and 2, the centripetal force is electrostatic force is responsible for the electron to move in the circular orbit, so that causes for the centripetal force, right? So from equation 1 and 2 we can write 1 by 4 pi epsilon naught E square divided by R square, that is equals to mv square divided by r, right? So in the RHS we have r, in the LHS r square get cancelled. So if we shift the r to RHS, 1 by 4 pi epsilon naught into E square is equals to mv square r, calling this third equation, right? So here we are going to find the radius of the hydrogen atom by using the Bohr's postulate, right? So from Bohr's postulate, so MVR is equals to NH by 2 pi, right? So MVR is the angular momentum. So angular momentum is equals to integral multiple of h by 2 pi, that is constant. So integral multiple is the n value, right? So squaring on both sides, so we get m square, b square, r square, that is equals to n square, h square divided by 4 pi square, calling this one as the fourth equation, right? So now divide 4, that is equation 4 by equation 3, right? So divide equation 4 by 3. So LHS m square v square r square divided by m v square r, that is equals to n square h square divided by 4 pi square divided by 1 by 4 pi epsilon naught into v square, right? So LHS terms mv square n square v square divided by here. So corresponding terms na divide ಮಾಡಬಹುದು, right? So here m square m r square r and v square get cancelled. In the LHS we having m v, right? Sorry, m r. So here in the RHS 4 get cancels, right? 1 pi square get cancels, right? So remaining is n square h square divided by, that is into epsilon naught v square, right? So we need the radius. So r is equals to n square h square epsilon naught divided by, so here pi m e square, right? So this is the radius of the nth orbit. For nth orbit means we need to write r n. So nth orbit anta kelirodrinda r n anta substitute ಮಾಡಬೇಕು, right? So this is the final expression. ಸೊ ಇದ್ರ ಜೊತೆಗೆ ಕಂಟಿನ್ಯೂಡ್ ಅಲ್ಲಿ ಬೋರ್ಸ್ ಆರ್ಬಿಟ್ ಅಂತ ಕೇಳಿದ್ರೆ n ವ್ಯಾಲ್ಯೂ 1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಸೊ rn becomes a. So a is equals to epsilon naught h square divided by pi m e square. So ಬೋರ್ಸ್ ಆರ್ಬಿಟ್ means first. So n ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ ನಮಗೆ 1 ಇರುತ್ತೆ. ಸೊ ಅದು ಏನಾಗುತ್ತೆ ನಮಗೆ ಬೋರ್ಸ್ ಆರ್ಬಿಟ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇಲ್ಲಿ nth ಆರ್ಡರ್ ಕೇಳಿರೋದ್ರಿಂದ ರೇಡಿಯಸ್ ಆಫ್ nth ಆರ್ಬಿಟ್ ಇರೋದು rn, right? So simple derivation is that first considered one nucleus. So electron is revolving around the nucleus with the speed v at a distance r from the nucleus, right? So here positive charge ide jotage negative charge ide. So due to the electrostatic force, that is Coulomb's law. So Coulomb's law apply ಮಾಡ್ಕೊಂಡು we are writing the force, that is Fv. So ಅದು ಯಾವುದು ಇರುತ್ತೆ ಅಂದ್ರೆ attractive force, right? So electron is attracting towards the nucleus, right? So and the electron is moving with speed v. So idu circular orbit alli move agbeku andre namge another force required ide. So that force is the centripetal force. So due to the centripetal force, any objects will move in a circular path or circular orbit, right? So that's why Fc is equals to mv square by r. So this centripetal force is always acting towards the center. So idu kuda namge towards the center ಆಗುತ್ತೆ. So hence these two forces will be the same. So ಎರಡು force ಕೂಡ balance ಆಗುತ್ತೆ. So hence mv square, that is 1 by 4 pi epsilon naught e square by r square is equals to mv square by r. So r cancel ಮಾಡಿ. So ಇದನ್ನ Bohr's postulate use ಮಾಡಿ ಬರಿತಾ ಇರೋದ್ರಿಂದ, so from the Bohr's postulate we can write mv r is equals to nh by 2 pi. So squaring this relation we get m square v square r square is equals to n square h square by 4 pi square. So divide equation 4 by equation 3, we get the final n, right? That is n square h square epsilon naught by pi m e square, right? So next, 35th question, state Bohr's postulate, right? So Bohr's postulate, so electron is revolving around the nucleus in only a definite orbits, right? That means permitted orbits. So those orbits we call as the stationary orbits. So we have three Bohr's postulate. So in that first postulate is electron revolving around the nucleus in only the permitted orbit. So ಇಲ್ಲಿ ನಮಗೆ number of orbits ಸಿಗುತ್ತೆ. So out of all the orbits, only permitted orbital ಮಾತ್ರ electrons ಏನಾಗುತ್ತೆ revolve ಆಗುತ್ತೆ. So ಅಂತ orbits ನ ನಾವೇನಂತ ಕರಿತೀವಿ stationary orbits ಅಂತ ಕರಿತೀವಿ. Right? So the revolving electron does not radiate any energy. So electron revolve ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ around the nucleus, it does not radiate any energy. So ಈ electron ಇಂದ ಯಾವುದೇ ತರದ energy ಏನಾಗೋದಿಲ್ಲ ನಮಗೆ radiate ಆಗೋದಿಲ್ಲ. So that one is the first Bohr's postulate. So first Bohr's postulate is electron revolving around the nucleus in only a particular orbit, that is the permitted orbit. So permitted orbits ಅಲ್ಲಿ ಮಾತ್ರ electrons ಏನಾಗುತ್ತೆ revolve ಆಗುತ್ತೆ, right? So ant orbits na navenanta kariತೀವಿ stationary orbits, right? So in that point only, so one more point, that is the revolving electron. So electron revolve ಆಗ್ತಾ ಇದ್ದಾಗ it does not radiate any energy. So electron revolving around the nucleus does not radiate any energy. That means it will not gives any radiations, right? So that one is the first Bohr's postulate, right? The second one is the electrons which are revolving around the nucleus, right? So electrons nucleus around revolve ಆಗ್ತಾ ಇದೆ in the stationary orbits, that is only in the permitted orbits. So these electrons having the angular moments, the electrons which are revolving in the stationary orbits having the angular momentum. Angular momentum is the integral multiple of nh by 2 pi. So that is the second postulate, right? So this point is the second postulate. So MVR is the angular momentum. So linear momentum ಗೊತ್ತಿದೆ, mass into velocity, right? So angular momentum is into its radius, right? So revolving around the nucleus, the electrons which are revolving in the stationary orbits having the angular momentum. So that angular momentum is equals to integral multiple. So integral multiple means n value, integral multiple of h by 2 pi, right? So this one is the second postulate, right? So on the third postulate is the atoms. So overall consider this atoms radiates energy only when it electron transition from higher energy level to the lower energy level, right? So ಇಲ್ಲಿ already ಹೇಳಿದ್ರೆ ತುಂಬಾ orbits ಇರುತ್ತೆ, right? This atom radiates energy. So it will radiate energy only when the electron is transition from higher state to lower state. So higher state in the lower state ge jump ಆದಾಗ ನಮಗೆ ಏನು emit ಆಗುತ್ತೆ, energy emit ಆಗುತ್ತೆ, that is E is equals to hν, right? So that is the third postulate. So first postulate ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ವಿ, revolving electron does not radiate any energy. So electron revolve ಆಗ್ತಾ ಇದ್ರೆ ಆ electron ಇಂದ ಯಾವುದೇ ತರದ energy radiate ಆಗಲ್ಲ, that means emit ಆಗೋದಿಲ್ಲ. So ಯಾವಾಗ emit ಆಗುತ್ತೆ ಅಂದ್ರೆ when it jumps, so higher energy state to lower energy. That means so n value ಇಲ್ಲಿ ನಮಗೆ 3 ಇರುತ್ತೆ, so ಇಲ್ಲಿ 2 ಇರುತ್ತೆ. So n value 3 ಇರೋದು higher energy compared to that of the n2. So when it jumps from third energy level to second energy level, then only it radiates the energy, right? So that is the third postulate, right? So these three are the Bohr's postulate. So tumba important, right? So tumba simple, right? I'll make a note on 6. So the first point is 35th. Bohr's postulates, right? So electrons revolve around the nucleus in an atom only in the permitted orbits called stationary orbits, right? So in this point only one sub point, revolving electron in the stationary orbit does not radiate energy. So orbit stationary orbital revolve ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ತರದ ಎನರ್ಜಿ ನಮಗೆ ರೇಡಿಯೇಟ್ ಆಗೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ revolving in the stationary orbit. So electron revolving in the stationary orbit having the angular momentum is integral multiple of nh by 2 pi. Right? So that one is the second postulate, and the third and the last one is atom radiates energy when electron is transition from higher energy level to lower energy level, right? So these are the three postulates, right? So simple is that ಒಂದೇನು ಹೇಳ್ತಿದೆ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಹತ್ರ ಓನ್ಲಿ ಇನ್ ಎ ಪರ್ಮಿಟೆಡ್ ಆರ್ಬಿಟ್, ಅಂತ ಆರ್ಬಿಟ್ ನಾವು ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ತರಹದ ರೇಡಿಯೇಷನ್ಸ್ ಎಮಿಟ್ ಆಗೋದಿಲ್ಲ. ಸೊ ರೇಡಿಯೇಷನ್ಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಎನರ್ಜಿ. ನೆಕ್ಸ್ಟ್, ದ ಎಲೆಕ್ಟ್ರಾನ್ ರಿವಾಲ್ವಿಂಗ್ ಇನ್ ದ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ ಹ್ಯಾವಿಂಗ್ ದ ಆಂಗುಲರ್ momentum, that value is equals to nh by 2 pi. So in the bracket you can write mvr is equals to nh by 2 pi, right? So that is the angular momentum. And the last point is total this atom radiates energy only when the electron is transition from higher energy state to the lower energy state, that is ef minus ei, that is equals to hν, right? So EF is the higher energy state, EI is the lower energy state, that is equals to hν. So hν is again the radiation, right? So when it is transition from higher energy to lower energy, then only the energies are liberated or energies are produced, right? So that is the third Bohr's postulate, right? So remaining we will continue in our next class, right? Thank you.